Hi everyone, this article is to explain how to set up wheel speed inputs and gear detection on the Adaptronic Modular ECUs. First of all, most cars have a tail shaft speed sensor on them from factory. This either connects to the ECU directly or to the dash, which then sends a signal to the ECU. We need the road speed to be able to do things like idle control in some cars, launch control, and gear detection. Almost all the speed sensors you'll find are basically magnetic in nature, but there are a couple of different types which have different effects on how the ECU needs to read the signal. As far as the ECU is concerned, there are two sorts of inputs that it can accept. One input is a variable frequency digital signal, so it gets pulled to ground with a varying frequency where the frequency corresponds to the speed. And the other is a reluctor sensor where the sensor generates a voltage. Again, the frequency of the signal determines the speed, but it's an analog signal and the ECU looks at the zero crossing. If the sensor itself has 2 wires, then it's probably a reluctor type sensor. If it has 3 wires, then it's probably a Hall effect type sensor and will give a digital output. On a lot of cars, they have a reluctor sensor that feeds into the dash, and the dash outputs a digital signal to the ECU. Either of these can be used with the ECU and just needs to be wired into the vehicle speed input. On plug and play ECUs, where there's a vehicle speed sensor fitted from factory, which is almost all cars, then this is already done in the vehicle's wiring and you don't need to do anything. So next you need to select the correct sensor type, so digital for a Hall effect sensor or a digital signal coming out of the dash, which is most cars, or reluctor for a reluctor signal, for example if you're wiring up to a 2-wire sensor directly from the ECU. On some older cars they had a mechanical speedo cable that went from the gearbox to the dash, and inside the dash was the sensor which drove the ECU. Now in some cases this was actually a magnetic reed switch, so there's a magnet which rotates on a shaft, and when the magnet passes the reed switch it closes the contacts. Because you've got mechanical contacts, the contacts actually bounce when they close. So instead of giving a single pulse, they give a dirty pulse if you like. So if you're using one of these sort of sensors, then you may need to turn up the filtering on the ECU. Once you've wired the wheel speed sensor into the ECU, the next step is to make sure that the sensor is actually working the ECU and triggering the input. For this you can go into the ECU data window and look at the vehicle speed input. This should change state as the wheel's rotated, and it should stay in a constant state when the wheel is stationary. Assuming that this is working, then you can calibrate the road speed. To do this, drive at a constant speed. So if you're a metric person, that'll be 50 kilometers an hour, and if you're an imperial person, that'll be 30 miles per hour, and then click on the calibrate road speed button in the software. After this, the road speed should read accurately. In a manual transmission car, you can now go through the gears and teach the ECU the ratio between the RPM and the road speed in each gear. This does not require driving at any specific speed. All you need to do is drive the car in each gear and click the learn button when you're in each gear. Then the software will show you the speed for every 1000 RPM in that specific gear, and as you're driving, the gear indicator in the gauges window should read correctly. This is useful when reviewing data logs to be able to see what the driver was doing at the time by which gear they were in. This helps with driver training and can also be used to allow the ECU to give different boosts in different gears on turbocharged cars. For use with traction control, you'll need to have individual wheel speed sensors on each wheel. Ideally they'd be ABS type sensors with lots and lots of teeth. You can trigger off the back of the wheel studs, however that doesn't give you enough teeth for accurate traction control. To calibrate these, you can go to a constant speed and then select the learn speed on each of the wheels at the same time. If you're on a 2-wheel drive dyno while you're doing this, you can take the values from the rear wheels and copy them manually into the front wheel speed sensor calibrations. If you've got staggered wheels where the front and rear rolling radii are different, then you'll have to do this on the street. Thanks very much.